Welcome to Frankensight and our YouTube channel Ask Frank 15. Today we are going to discuss tcpdump filters for capturing ARP traffic. The address resolution protocol matches physical addresses with IP addresses and caches results for a given period of time, usually 10 to 20 minutes. First of all, let's look at the ARP message. Now what I've done here is I've kind of outlined what's in an ARP message. The title for the lesson is using tcpdump to capture ARP. So first of all, ARP is used for matching data link addresses with a layer 3 address, usually an IP address. So let's go through the fields in the ARP message and the byte offsets which correspond with them. First of all, we have the hardware type, such as Ethernet, which is a value of 1 at offset 0. Next, we have the protocol type. The type of layer 3 address used in the message, usually IP, is at offset 2. Next is the hardware address length, which for a MAC address is 6. And that's at offset 4. Again, these offsets correspond to bytes. So offset 0, the first byte, 2, the third byte, 4, the fifth byte. So 4, we're looking at the protocol address length. So for IP, this is 4 bytes, and that's at offset 5. 5 is the all-important op code. What kind of ARP message is this? This is a byte offset 7. Here are the codes. An ARP request is 1. ARP reply is 2. Then we go into reverse ARP, etc. Most important are going to be request and reply. So 6 is going to be the sender hardware address, the physical address of the device sending the message. And this is at offset 8 through 13. Since it's a MAC address, and this is designated earlier in the message, but in this case we're just going to assume it's a MAC address, and that's going to be 6 bytes. Next is the sender protocol address, the IP address, probably an IP address of the device sending the message, and that's at offset 14 through 17, 4 bytes. Next is the target hardware address, the physical address of the device, which is the destination. So offset 18 through 24, again 6 bytes, if it's a MAC address. And then the target protocol address, the IP address of the device this message is being sent to, offset 25 through 28. Usually the target hardware address is what we're looking for with ARP requests. So if you look for that in ARP requests, you're probably not going to find anything. So let's exit out of here and go to our first example, which is going to be ARP request.txt. So what I did is I outlined the tcpdump capture, talked about it a little bit, and then I had to pre-capture because the ARP was being a bit slow on the network I'm on. So and all I'm doing is capturing from the wireless access point at the house. So the actual ARP request is again at offset. So it offsets 6 and 7. In this case, it captures at 7. Value 1 is what we're looking for. Value 1 is request. And then we used N because we don't want name resolution. We're just using IP addresses. And then verbose output. And here's the capture. We have ARP, hardware, Ethernet, length 6. IPv4 is the protocol, length 4. And it's a request. And it's saying, who has this IP address, send me your MAC address, and I'm at 21.1 or 21.141. So next let's do response. So in spite of what this says, this is actually an ARP response. I just forgot to change it. But The capture script is going to be almost the same thing, but we're going to use a value of 2 at byte offset 7 instead of 1. 1 again is request, and this is actually response. So here's our capture, and it says reply instead of request. So next, we're going to move beyond that, and we're going to look at a compound statement. We're going to look at ARP Ethernet request. So this is a compound statement. I forgot to change that here too. What we're saying here is ARP byte offset 1 equals 1. That means Ethernet. So the hardware type again is at offset 1, and the value 1 means Ethernet. And here we have ARP 7 equals 1, and that means opcode value 1, which is a request. So we're saying we want Ethernet and request. Now here's the capture for it. We have all requests and all Ethernet. It would be all Ethernet anyway in this case. But yeah, so that's compound. And next, we're going to look at sender IP address. So ARP sender IP address. So we're looking at byte offset 14, 15, 16, and 17. And since we're looking at the actual individual bytes, I've split up the IP address into 4 sections corresponding to the 4 bytes. So I have 172, 21, 21, and 1. And then again, N for no name resolution, and then VVV for verbose output. And here's the capture. So we have 172, 21, 21, blah, blah, blah. Tell this source IP address 21, 21, 1. That's, again, sender IP address. It's called sender IP in ARP. So, next we're going to look at sender MAC. And this is going to be our last example. ARP, capture requests for sender MAC address. This one gets a little long because we're capturing for 6 bytes, and then I've added a compound statement too. So byte offset 8, 9, 10, 11, 12, 13 we're capturing for, and I've converted the hex from the MAC address to decimal for each of these. And then after that, I added an AND operator and added ARP request. So we're looking for an ARP request with sender MAC address designated here. And here's our capture. I can't actually see the, well, the sender MAC is this guy here, 21.1. That's who we're looking for. It corresponds to that IP address. And they're all requests. So that's it. That's ARP in ridiculous detail for tcpdump.